Welcome, Calculus BC. This is lesson 8.1, differential equations. Let's go. So what is a differential equation? Well, you might have seen this word before, differential, and it's related to doing a derivative. So differential equations are equations have an equal sign. So derivative equations, basically you have an equal sign and you have derivatives. So y primes or dy dx. So here's some example of differential equations. X plus 2y times y prime equals 0 because there's a y prime. Or this dy dx plus y squared times x is 2x. Or even a double derivative like this one. So these are all differential equations. Well, what can we do with differential equations? Or what do we sometimes what we can do is find the general solution. So sometimes we're just differential equations are just an equation written in a different form. And there's some applications of that. But sometimes we want to like write it instead of in that weird form, we want to put it in like a y equals form. So that's what we mean by a general solution. So you're going to basically get rid of the differential parts, or not necessarily a y equals form, just with x's and y's in it, but you're going to have a plus c in there somewhere because when you have to integrate to get there, and integrate, you're always going to have that plus constant. Now, you might also want to find the particular solution. So all you have to do for a particular solution is figure out what that plus c is, and they usually give you some kind of initial condition. So the thing we're going to practice today is just taking a differential equation and figuring out a general solution or a particular solution. But how do we do that? And here's a bunch of here's a big procedure. There's a lot of words in there, but let's go through this. So first thing, ultimately we're going to integrate at some point. But the first thing we're going to have to rewrite the y primes as dy dx. Sometimes you have to do that. It's easier this way. Now, there's all these steps of multiplying both sides of the equation by dx. Sometimes you have to do this, but here's the big thing. Separate the variables. You want to have an equal sign. You want to have all the y's and the dy's on one side, and you want to have the x's and the dx on the other side. All right? So as long as they're separated, and then after you separate them, we can actually integrate both sides. So you can't integrate until you have the dy's and dx's on separate sides. So after you integrate this, sometimes we're asked to solve for y, so put it in a y equals form. And then sometimes you have to find the particular solution, so you plug in to find that. All right. So again, the key part here is we want to separate the variables and then to eventually integrate. And let's see some examples of that. So here's that one of those that popped up earlier. X plus 2y prime equals 0. So that first step, I'm going to change it to dy dx. So x plus 2y times dy over dx equals 0. Now, you don't have to do whatever algebra you have to do to get to the solution you want. Let's multiply. We can multiply by dx first. That's a good idea because we want to actually get these dy's and dx's in the top, the numerator. So we're going to multiply everything by dx and every term. And then that means these two cancel. So left with x dx plus 2y dy equals 0. All right. And I like to have dx as dy's. We'll make this the dy side, and I want to make this the x side. So I'm actually going to subtract x dx on both sides. X dx, cancel. So 2y dy equals negative x dx. Now we have separated. So what I'm going to do now is integrate. So do the little integration sign. And integral, or antiderivative 2y, is going to be y squared. So it's 2y squared over 2, but those cancel out. So just y squared. Integral of negative x is going to be negative x squared over 2. Now remember, you need to have a plus c somewhere. So I'm usually just going to put it on the x side. Technically, we have like a plus c on both sides, but because of how plus c is any constant, you only need it on one side, so let's just put it on the right side. Don't need this. And there's my answer. There's a general solution for this equation. Y squared equals negative x squared over 2 plus c. All right, so another question, find an equation of a function. That means, that's a keyword, I want it in y equals form, which contains the point 0, 3. This is our initial condition. and whose slope is this. So when I say slope, that means dy dx equals that for each point on the curve. So again, an equation of the function, that means I want to find something in y equals form. An initial point, that means you're going to solve for your plus c. And at point 0, 0, 3, that means x equals 0 and y equals -3. And a slope is dy dx. That means that's an equation or a differential equation. Dy dx equals x e to the x squared over y. All right, so let's do our steps to find the general solution and eventually our particular solution. So the first thing that we were told to do, and usually works, is multiply by dx on both sides. These cancel. So dy equals x e to the x squared over y dx. And I want to get the y's and the x's, so this y has to go. So I'm going to multiply by y on both sides. Cancel, cancel. Y dy is x e to the x squared dx. Cool. So you integrate like that. And this y is going to be y squared over 2. And then this one. Like, uh-oh, how do I integrate that? And then you go back to your brain and go, oh, use substitution. So u is x squared, du is dx, or 2x dx. So I need a 2, I need to do 1/2 here. So I'm going to do 1/2 integral, that's 2x dx is my du. So it'll be e to the u. Integral of that's going to be 1/2 e to the u plus c, which is 1/2 e to the x squared plus c. So y squared over 2 equals that. And I wanted to solve for y eventually. We'll come up to that work later. So I'm going to multiply both sides by 2. Remember, everything times 2. So it's going to be y squared equals 2 times 1/2 will just be 1. So e to the x squared plus 2 times c. Nice thing when you say 2 times c, it's still just c. It didn't change that c at all because it's a constant. We don't know what it is. All right. And I want to get y by itself, so I have to square root both sides. I have to square root. So I'm going to do this. So my y equals the square root of e to the x squared plus c. Okay, so this is my general, but it wanted me to find a particular with initial point 0, -3. Oh, so remember this is actually, when you square root, it's y plus or minus. Now, a hint here. So usually I would just plug in my x and the y value and figure out your whatever your c is. So -3 equals, let's go. So I'm gonna leave that plus and minus. We'll talk about that later. So e to the 0 squared plus c, which is going to be 1 plus c. Now, the reason it's going to actually be minus here, because it can't be plus because the y is negative, so I know it's got to be a minus the square root. So -3 equals -1 plus c. What I'm going to do is I'm going to square both sides. So you square the whole thing, it becomes 9 equals 1 plus c. You might be able to eyeball this anyways. So c equals 8. So my actual answer is y equals negative square root of e to the x squared plus 8. Yeah, that was kind of a lot of work. Yeah, they're not always like this. We'll do more in class. That's the idea.